Good afternoon and welcome. My name is Tom Carpenter and I'm the CTO here at CWNP. So we're going to go ahead and get started today with this topic, which is a foundations topic. However, these foundational concepts are absolutely essential to implementing an effective wireless LAN. If we don't know how RF works, we can't make RF work the way we want it to. And so it's very important to understand these foundations. Therefore, even if you've been around Wi-Fi for a while, I'm sure you'll hear some tips and tricks that will help you better optimize your networks as well. Okay, so let's talk about our agenda for today and what we'll be talking about. First of all, we're going to be looking at RF basics. So before we get into the 5 RF fundamentals, I do want to review some basics with you to make sure you have the terminology down. Then we'll get into the 5 RF fundamentals, which are channels, behaviors, measurements, interference, and analysis. And we'll look at those one by one. So now let's begin talking about the 5 RF fundamentals, or the 5 fundamentals of RF that you have to know for wireless LAN success. The first one is channels. And we have different channels depending on whether we're in 2.4 gigahertz or 5 gigahertz. And we're about to see why I said that 5 gigahertz is so much better for implementing wireless LANs. In 2.4 gigahertz, you have a total of 14 channels. However, these 14 channels are spaced only 5 megahertz apart based on their center frequency. So you'll notice in the screen that channel 1 centers on 2.412 gigahertz. And channel 2 centers on 2.417 gigahertz. So notice they're only 5 megahertz apart. However, so 802.11n and 802.11g use OFDM and they use 20 megahertz channels. 802.11b and the original 802.11 use 22 megahertz channels. So the point is that because the channels are 20 or 22 megahertz wide, when we actually transmit, and they're centered on a center frequency, and these numbered channels are only 5 megahertz apart, that tells you that using channel 1, the actual signal itself is going to span channels 1, 2, and 3. And then the side bands, the extra energy that is just radiated as we generate a signal, is going to go even up to 4 and possibly 5, depending on the output power. This is why we say in 2.4 gigahertz, when you only have 11 channels, which is all we have in the US and in many other regions of the world, you only have 3 real channels that you can use. Even though there are 11, we can only use 3 of them, channel 1, channel 6, and channel 11. This is why hopefully in your enterprise wireless LAN on 2.4 gigahertz, when you do a scan of the environment, you see a lot of APs on channels 1, channel 6, and channel 11. Hopefully you don't see any APs on channels 2, 3, 4, 5, 7, 8, 9, and 10. Sadly, in mixed environments, particularly in shared spaces like office spaces and things like that where multiple companies are represented, you see nearly all of these channels utilized. And this causes a lot of what we call adjacent channel interference. The channels are stepping on each other because their signals invade the other channel bandwidth. So 2.4 gigahertz, here's why it is so cluttered. We really only have 3 channels, and then add on to that all of the many devices that are actually there operating in 2.4 gigahertz.